Okay, we are recording. Let's begin. Okay, for the first question, it says the null alternative hypotheses are given. Is this test a left tail test, a right tail test, or a two tail test? And because H1, guys, has not equal sign, then it is a what? A two tail test. When it is a left tail test, if H1 has this sign, then there will be a left tail test. And when H1 has this greater sign, then it will be a right tail test. Number two, the mean repair bill of cars is greater than 110. Write the null and the alternative hypotheses. So you guys put HO, H1, greater is this sign, mean, greater than 110. That's H1. And then you guys know that HO has to have an equal sign. So the mean will be equal to 1. Okay. Next question. 3. A referendum for an upcoming election is favored by more than half of the voters. Identify type 1 errors and type 2 errors. Okay, let me just give you the definition. It's mainly the definition. More than half, it's a proportion. More than half, more than 50%. So more than half. And P will be equal to what? 50%. That's HOH1. What is type 1 error, guys? Type 1 error means you reject the null hypothesis when it is true. That means the null hypothesis is true, but you end up rejecting it in favor, just of H1. So that would be a type 1 error when you make this mistake. What is type 2 error, guys? Type 2 error is when you fail to reject the null hypothesis when it is false. So this is false, but you fail, just to acknowledge that. If this is false, guys, that means this one is true. They can't be both false and they can't be both true. If one is false, automatically the second one is true, because these are opposite statements. They compete with each other. So if you fail to reject something that is false, that means you committed a type 2 error. That's the definition of type 2. 4. If we don't reject the null hypothesis when the null hypothesis is an error, what type of mistake did we make, guys? Well, I just mentioned that. If you don't reject the null hypothesis when it is an error, that means when it is false. This is type what, guys? Type 2. So when you do statistical studies, guys, it is possible that you commit a type 1 or type 2 error. It's going to happen. There's always a mistake, just in statistics, because we're not surveying the entire population. When you work with a sample, there's always a likelihood that you commit an error, but we try to minimize the error. That's the thing. Number 5, the mean age of principals in the local school district is 53.6 years. So they said the mean age is means equal, 53.6. How do I write H1? H1 will be the competing statement. What would be competing with equal, not equal? So that's the claim right here. If you perform a hypothesis test, how should you interpret a decision that rejects the null hypothesis? So if you reject HO, what do you say, guys? This will be, if I give you this one on the test, it will be a multiple choice. So you would select, just one of 4 or 5 choices. If you reject HO, what do you say about the claim? The claim happened to be in HO, and you reject HO, you say there is enough evidence to reject the claim. And I want to bring something to your attention, guys, before we start with number 7. You only use in your final statement the word reject if the claim is in the null hypothesis. If the claim is not in the null hypothesis, it's in the H1, which is mostly the case, you will never use the word reject in your conclusion. You will use the word support in your conclusion. Number 6. The dean of a major university claims that the mean number of hours students study at her university per day is at most 4.2 hours. How do you write the sign at most, guys? What's the sign for at most? Can someone tell me? You can put it in the chat if you like. How do you write? Well, probably you can type it in the chat. Do you know what at most, guys, means less than or equal to? And what would be the complement of at most? The opposite of at most will be greater than. So if I state HO and H1, guys, it will be like this. So it says the mean. This is at most. And this is a greater than. The greater than has to be in the alternative hypothesis. But since your null hypothesis, guys, cannot have any signs but the equal sign, we will replace this with the equal sign. And this is the claim. How would you interpret a decision that fails to reject the null hypothesis? We cannot reject the null hypothesis. We cannot reject the null hypothesis, guys, and the claim happened to be in the null hypothesis. So we say we don't have enough evidence to reject the claim. Now, probably you're asking me, how do you say the word reject? We're not saying the word support because I told you, if the claim happened to be in the null hypothesis, your conclusion should be, we have enough evidence to reject the claim or we don't have enough evidence to reject the claim. Since we failed to reject the null hypothesis, we just say not enough evidence to reject the claim. Okay, let me just highlight something before we start working the problems from chapter 10. I want you to pay good attention to this. I shared this with you in several occasions, email. It is in Moodle, but I would like, just to say something about it. You guys, most of the question you're going to have on the test, if not all of them, you're going to be performing a hypothesis test. So you're going to have to state HO and H1. And the claim, guys, is going to be either in HO and H1. But I can tell you most of the questions, the claim is going to turn out to, in real life, most of the claim will turn out to be in H1. So let's say the claim is going to be here. That's the first scenario. Let's say you reject HO. So the p-value turned out to be less than alpha, and you reject HO. How do you write your conclusion? If you reject HO, guys, that you're saying this is bad, HO is bad, that means H1 is good. Then you say there is enough evidence at the alpha level of significance to support the claim that whatever the claim is, just write it down. This is if you reject HO. So if we reject HO, we support the claim. Now, what about if you fail to reject HO? What do you say? So let's say the p-value here is more than alpha. Here's what you say. You cannot reject HO, guys. If you can't reject the first one, that means probably you accept it. It means that you cannot support H1. So what do you say? You say this. Not enough evidence to support the claim. Did you notice, guys, in my conclusion, I did not use the word reject because my claim is in H1. Now, what about, just if the claim happened to be in HO? It could happen, but not as common as the claim being in H1. So what about if the claim is here? Just like the previous two questions that I just did. What about if you reject HO? What do you say? Okay, I'm going to tell you what you say if you reject HO. If you reject HO and the claim happened to be HO, you say, I reject the claim. I have enough evidence to reject the claim. Now, what about if you fail to reject HO? What do you say? You fail to reject HO and the claim happened to be HO. That means you fail to reject the claim. Just change the name H0 to claim. Just put the word claim there. So not enough evidence to reject the claim. These are the four scenarios, guys, that you will be faced with every time, just you study the claim. But I can tell you the most common scenarios that you're going to be faced with is these two here. Because when the claim is in H1, most of the time, it doesn't mean that you won't have a question where the claim is in HO, but I'm telling you most of the questions will have the claim turn out, just to be in H1, because in real life, this is how it is. Any questions about this part? And I'm going to demo this part, guys. You're going to see that we're going to demo this part in every single question. That's what I'm talking about right here. Let's begin. Number 7. An airline claims that no-show rate means a proportion, for passengers is less than 5%. In a sample of 420 randomly selected reservations, 19 were no-shows. At alpha equal 1%, test the airline's claim. And don't worry about this part right here. Okay. HO, guys, and HA1. We want to test the claim that P is less than 5%. That's the claim. You see, it's in H1, not in HO. And HO will be P equals what? 5%. He gives me X and N. He says X is 19 out of a sample of 420. This is a proportion test. In order to perform this test, guys, on the calculator, you will use one prop z-test. I'll perform that on the calculator, and then I'll show you how to use StatCrunch for this one as well. It's a very important question. Definitely you're going to see a question like that. So you go to Stat, Tests, one prop z-test. P is 0.05. You see, I did that this morning with my group. 19 is X, N is 420. Here, guys, you have to choose the alternative sign. So the less than, make sure to select this properly. And then hit calculate. And this is Z, test statistic. I will need 5 steps from you guys for each question. And I'll list them for you in a second. P-value is 0.3272. You will need, guys, the null and the alternative statement. Tell me where the claim is. You need the test statistic. You need the p-value. Now we're going to make a decision. Do we reject HO or fail to reject HO? Well, this number is bigger than alpha, guys. That means we what? Fail to reject HO. If you fail to reject HO, how do you write the conclusion? Let me just write it down this time. There is not. When you fail to reject HO, you start with there is not. You have to have this right here. There is not enough evidence at the 1% level of significance. What's the magic word, guys? Not reject, the word what? Support. To support the claim. And you cannot stop right here, guys. You will not get full credit if you stop right here. A reader who's reading, just your problem, want to know what the claim was. To support the claim, just copy and paste, guys. That no-show rate for passengers is less than what? 5%. Any questions? You do this, guys, you get for complete marks because you highlighted, just all the steps for this one. Step 1, step 2, step 3, step 4, step 5. And step 5 is an extremely important statement because that's the conclusion. Do you support the claim or you don't support it? We're saying we don't support it. We don't have enough evidence to support the claim. Now, how do you use StatCrunch for this one? Let me show you. Okay, let me share the screen. Okay, you can see the screen right now. So you go to Stat, Proportion Stat, one sample, it's only one sample with summary. Number of successes is X, which is 19. Number of observation is 420. Now here we need 0.05. This is 0.05. And we need the less than for the alternative hypothesis. And just hit compute, guys, and look. Let me show you. This is the test statistic Z, negative 0.45, and this is the p-value. This is exactly what we got using the calculator. Any questions? Next question. Number 8. A local retailer claims that the mean wait time is less than 9 minutes. A random sample of 20 waiting times has a mean of 7.4 minutes. So let's write the null and the alternative, guys. Mean is less than 9 minutes. That's the claim. And the claim, again, turned out to be an H1, guys. Don't be surprised. 9 minutes. Now, N is 20. Has a mean of 7.4. X bar is 7.4. With a standard deviation, S, he's talking about the sample, guys, 2.1 minutes, and alpha is 0.01. Test the claim. Okay, what test are we going to be using here? It's a t-test. Oh, and here the claim is not in HO because he says less than. How do I know it is in H1 here? Because look what he says. He says a local retailer claims that the mean wait time is less than. Less than is this sign. And we know that this sign belongs to H1. So if your claim, guys, is about less than, more than, or not equal, definitely is going to be in H1. But if he tell you a local retailer claims that the mean wait time is equal to 9 minutes, equal means in the null hypothesis, then the claim will be in the null hypothesis. But most of the time, guys, it's going to be one of those, as I told you. So it's going to be likely in H1. Or a right tail when the alternative hypothesis has a greater sign. A left tail when it is less. This is less than, that means it's a left tail test. These are questions I'm getting in the chat, guys. All right. So this is a t-test. When you guys test the mean, you have two kinds of tests that you can perform. You have a t-test and you have a z-test. Let me tell you when do you use the z-test, it's going to come next. It's not as popular as the t-test, but we use it sometimes. We will use the z-test, guys, only if he gives us the population standard deviation. So because here he didn't give me a population, he gave me the sample standard deviation of 2.1, I will be using the t-test. So here only when sigma is known. You will see a wording of a problem where sigma is known, so you will know when to use the z-test. But the common test, guys, is the t-test. So how do you do this one? Let's do it on the calculator. Stat, test, t-test, watch. Input, mu0, we're testing against the number 9. X bar is 7.4. S is 2.1. N is 20. And don't forget, guys, you choose the alternative sign from here before you proceed. The alternative sign is less than. I have to choose this one. And I can hit calculate or draw. I'm just going to do T, calculate. So T, I will tell you guys what to round to. So T is usually to 3 decimal places, or T0, he calls it T0 in the book, 407. And p-value is, you can see it on the screen, 0.0015. Do you guys agree with me this is less than alpha? Then we're going to reject what? HO. And I'm going to write the conclusion for you guys. There is, when you reject HO, guys, you support H1 because this is bad. You're telling me that this is bad. That means the second one is good. There is enough evidence at the 1% level of significance to support the claim that the mean wait time is less than 9 months. I'm done. This is a complete question with all the steps, guys. Step 1, state HO and H1 and say where the claim is. Step 2, test the statistics. Step 3, p-value. Step 4, decide to reject or fail to reject HO. And step 5, write the conclusion in the context of the claim. All right, let's see. A right tail test is when the sign is and the alternative is greater than. But look at the sign right here. It's less than. That's a left tail test. When it is greater than in here, it will be called the right tail test. And when the sign here is not equal, that means it's a two-tailed test. Because when I say x is not equal to 5, that means x could be bigger than 5 or smaller than 5. That's why they call it a two-tailed test. Now, how do you use StatCrunch in this one? Let's share the screen with you. And let me do this. And you guys, can you confirm that you can see the shared screen? So it's tstat. You go to tstat, one sample with summary, and then put the sample mean, which is 7.4. Sample standard deviation, what was it in the question? 2.1. Sample size, how many in the samples? 20. We're testing against the number 9, and we need to test that the mean is less than 9. Compute. And look, guys, this is what we got. That's exactly what I got, negative 3.407. And look at the p-value, 0.0015. Okay, less than that. Next question. Okay. In 2010, the mean number of pets owned per household was 1.9. A poll of 1,023 households, so N is 1,023, conducted this year reported that the mean number of pets owned per household, so from the sample, the mean was 1.8. Okay, now I wanted to pay attention to this, guys. This is a unique problem here. Usually it's not the case, but I thought to just put that there so you be aware when to use a z-test. You notice here what it says, assuming sigma, not S. Sigma is the population standard deviation. When he gives you sigma, you cannot use a t-test. You have to use a z-distribution, z-test. So this is the only time where you use z, guys. Assuming sigma is 1.1. I want to put z-test right away because he gives me sigma. Is there sufficient evidence to support the claim that the mean number of pets owned has changed since 2010? We know it was 1.9 and he's asking us if that has changed. Has changed means, guys, different from 1.9. So it will be HO mean equals 1.9. H1 would be mean not equal to 1.9, and that's the claim. It is a z-test, and let me show you how to use the calculator for this one, and then I'll show you StatCrunch after that. You go to stat test, it's the first one on the calculator screen. Mu0, we're testing against 1.9. See here, the prompt, guys, it doesn't say S, it says sigma. So you just enter this value, 1.1. X bar is 1.8. N is 1,023. Use sample size and not equal. You see how I selected not equal? And then you can do calculate. So Z is negative 2.91. Z0 is negative 2.91. P-value is 0.0036. And would you guys agree with me that this p-value is so small, so it's less than alpha? We reject HO. And what would be the conclusion, guys? The conclusion would be there is enough evidence at the 10% level of significance to support the claim that the mean number of pets owned has changed since 2010. How do you use StatCrunch? Let's do this quickly. We're going to share the screen. We're going to get rid of this. You go to stat. You see, not t-stat, you have to use z-stat now. For StatCrunch user, you use z here, which is not very common, but for this question, one sample with summary, and then sample mean is 1.8. Population standard deviation, he says it's what? 1.1. Sample size is 1023. So here we're testing against 1.9 and choose not equal. Yeah, it is selected already, and just hit compute, guys, and look. Negative 2.91 and 0.0036, which is less than alpha. All right. Next question. I want to add just something right here. Same 11 people. What do you guys think of those two samples? Are they dependent or independent? Sample one is pre-training blood pressure of 11 people. Here, post-training blood pressure of the same 11 people. What would you think? Dependent or independent?
Dependent.
I agree. It's about the same 11 people before and after action. These are dependent samples. Okay, next question. Okay, this, if you want to know, guys, this is 11.1. Testing the difference between two proportions. Okay, let's do one. You're definitely gonna have questions from 11.1, 11.2, and 11.3. To test the effectiveness of a new drug designed to relieve flu symptoms, 200 patients were randomly selected and divided in two equal groups. So each group is 100. So group 1 and group 2. N1 is 100, N2 is 100. One group of 100 patients was given a pill containing the drug, while the other group was given placebo. Placebo means nothing, water pill. What can we conclude about the effectiveness of the drug if 62 of those actually taking the drug felt a benefit from taking the drug? So X1 is 62. And while 41 of the patient taking placebo felt a benefit, so X2 is 41. You have two groups, guys, here. Here you want to test the difference between two proportions, P1 and P2. HO, it's going to be, we know HO already, guys. It has to be an equal statement. Can a student tell me what sign we're going to put here? You have a choice of 3 of them.
Not equal to.
Remember, P1 stands for the ones who took the drug, and P2, the ones who did not take the drug, and want to see if the drug, just did really a better job. So what sign would you use in H1? The sign that you put, guys, is going to decide the fate of the problem, whether it's going to be correct or not correct. So that's why it's very, very important to understand how to state the null. I know it's a bit vague here. It says effective, and now, guys, you're trying to figure out what does he mean by effective. But we should know what effective means. Effective and better than placebo. Better means the proportion of patient who benefit will be what? What sign is it going to be?
Less than.
Greater. Andrew put in the chat, great. It should be greater because you want the drug, just to help better, than not taking anything. So the greater sign will be the correct sign. You want a hint, guys? Watch. This is 62 out of 100. This is 41 out of 100. It looks like this is bigger than that one. That's what we wanted to test. So I'm just going to delete those. And this is the claim. We're going to be using two prop z-test, two proportion z-test. And watch, guys. Stat tests, two prop z-test. Okay. X1, 62. N1, 100. X2, 41. N2, 100. And now I want to check that P1 is greater than P2. You know what, guys? I'm just going to pretend that I made a mistake, and I show you how you can figure out that you made a mistake. Let me put less than by mistake. When you put less than, guys, you should expect the test statistic to be negative. And when you put greater than, you should expect the test statistic to be positive. So let me put less than. Look at the test statistic, guys. See, it turns out to be positive. That can't be the case. If you put should be on the left, you should be on the negative side, but we were not. That means we made a mistake. So I'll just go back and fix it. Look, guys, 2 point. Look at the positive with the greater than match perfectly. All you need to copy, guys, this step and that step, and you're done. So Z0 is 2.97. You can put Z, it doesn't matter. It's up to you. The book uses Z0. So p-value is 0.0015. And do you guys agree with me that the p-value is less than alpha? Alpha is what, 0.05? That's less than 0. So you reject HO. And if you reject HO, I've said that already for the 10th time today. If you reject HO, guys, and the claim is in H1, you support the claim. There is enough evidence at the 5% level of significance to support. Don't stop at the word claim, guys. You have to say what the claim is. To support the claim about, you know, just the drug being effective in reducing and relieving the flu symptoms. That's it. How do you use StatCrunch for this one? I know some of you will be using StatCrunch. Okay, let's see. Share screen. Let me close this. You go to stat, proportion stat. But look, guys, this time is not one sample. You choose 2 samples with summary, not with data. I don't have the actual data. Number of successes, X1, which is 62. Number of observation, which is N1. Number of successes, which is 41. Observation, 100. And we want to test that P1 is greater than P2. Just select the sign and leave the 0 here. P1 minus P2 equal to 0 is the same as P1 equals P2. It means the same thing. I just hit compute and look, guys, you get the same results. Z is 2.97 and p-value is 0.0015. Let me stop sharing, continue. Okay, this one, guys, that's section 11.2. This is the case of paired data or dependent samples. Okay, I'm gonna give you a hint, guys. If you see a table with before and after action items, that means it's about dependent sample. This is section 11.2. And the way we work with 11.2 is different, you know, from the other sections. So we're gonna perform the hypothesis test in a different way, 11.2. A physician claims that a person's diastolic blood pressure can be lowered if instead of taking a drug, the person meditates each evening. 10 subjects are randomly selected and pre-tested. Their blood pressure measured in millimeters of mercury are listed below. The 10 patients are instructed in basic meditation and told to practice it for 1 month. At the end of the month, they take their blood pressure again. Test the physician's claim. If you guys agree with me that this is a paired data set, that these are dependent, you know, just samples, then this is how we're gonna proceed. You will need to find the difference, T. Okay, let's do the difference. Do the first minus the second. 85 minus 82 is 3. 96 minus 90 is 6. 92 minus 92, 0. 83 minus 75 is what? 8. 80 minus 74 is 6. 91 minus 80 is 9. 79 minus 82 is a negative 3. 98 minus 88 is 10. 93 minus 89 is 4. And 96 minus 80 is 16. Let me ask you a question, guys. You can, if you don't want to talk, you just answer in the chat. For patient number 1, did meditation works? his blood pressure or her blood pressure went from 85 to 82. Did it work, yes or no? It lowered it, right? It did lower the blood pressure. So it worked for this person. Did it work for the second one from 96 to 90? Yes. Did it work for this guy, number 3, guys? What do you think?
No.
No, it didn't do anything. So I'm going to put an X. Did it work for 83 to 75? Yes. From 80 to 74, it went down. That's good. You don't want the blood pressure to be on the high side. 91 minus 80. That it worked. This guy, what do you think for patient number 7?
It didn't.
It didn't. It did. Let me tell you why I'm doing this, guys, because I'm going to give you a hint in how to state the null and the alternative hypothesis. For the ones that I put a check mark green, that means it worked. What's the sign of the difference, positive or negative? Those numbers that we got, are they positive or negative? Not for the ones with X, for the one with check marks. Are they positive or negative?
They're positive.
That's what you need to test, guys. You need to test the difference of being positive, and this is how you write it down. Mean of the difference greater than 0, mean of the difference equal to 0, and that's the claim. You know what? This is what would confuse students for this test. Instead of putting greater than 0, students, they put less than 0, and they end up, just with the wrong test results. But this is how I would figure it out if I were you guys. Just take, just one, and see if that difference, just would work in favor of the claim. If it does, use the sign that you see in the difference. So that's a plus. We should be testing mu of t greater than 0. This is a t-test, guys. It's going to be a t-test. Forget about this and forget about that. We're done with it. We just need the difference. We need to test the difference. So here's how you do it on the calculator. You go to stat, edit, and you input the data first. Let me just clear this one. So I'm going to input the data. 3, 6, 0, 8, 6, 9, -3, sorry. 10, 4, 16. And then you go to stat, tests, t-test. Watch, guys, t-test. Data, not stats now, not summary. I don't have summary. I have the actual data. So just put data. In section 11.2, you're testing against 0 always. So just put 0 here. It's an L1. Frequency, guys, don't ever touch this one. Leave it at 1 always. And we need to test it's greater than 0. You know what, guys? Let's say you make a mistake and put less than 0, less than. I want to show you how you can figure out that you did a mistake. Watch. So don't write anything here. What's the test statistic? 3.47. That's a positive, but you chose to test less than. That doesn't correlate well. If it is a positive, you should have the right sign, which is a greater sign. So I'm just gonna go back, stat, tests, t-test, sorry. And you know what? One more thing I want to show you that where you can tell that you made a mistake. Let me show you. Look at the p-value, guys. It's almost 1. That can't be the case. You can't have a p-value that big. That's too big. That means it's the other way around. So just go back to stat tests. T is 3.479. And p-value, look at the p-value, guys. It's small, 0.035. Watch. Which is less than alpha. Reject HO. So it's not a good day today for HO. Been rejecting HO all the time. If you reject HO, what do you say, guys? There is enough evidence at the 1% level of significance to support the claim that meditation whatever. Okay, the claim that a person's diastolic blood pressure can be lowered if instead of taking a drug, the person meditates each evening. That's what you write down. If you use StatCrunch, guys, let's do this with StatCrunch. You have to do some math here. You have to do some data entry. So you can actually do it with putting the two sets and choose paired, but since I did the minuses already, so I'm just gonna typing in, guys. You can type in. It takes, you know, just less than a minute, you know, just to type the data. So it's not a big deal. I won't give you any numbers that are ugly, you know, just to type, or so it should be okay just to do it. And just go to data, to stat, sorry, T-stat, one sample, but not with summary this time, with data, because I have the data. Select the variable.
You're doing proportions.
What is it?
You're doing proportions.
Oh, let me see. Thanks
Yeah,
for
you
noticing.
accidentally click proportions.
Let's see. T-stat. I have the screen is bothering me here. Okay, T-stat, one sample with data. Oops, not two samples. Do it one more time. T-stat, one sample with data. Right here. Again, 0, we have the 0 there, great. Greater than 0, guys, that's what we want. And bingo, compute. And let's show you the results. There you go, exactly what I got. Next question, stop share. Now we're doing 11.3. And because this section is important, guys, very important, I have 2 questions from 11.3. But it's easy to perform this. So 11.3. A local restaurant claims that the waiting time for its patron to be served is the lowest in the area. A competitor restaurant checks the waiting time at both restaurants. The samples are listed below. Test the restaurant's claim. Okay, you have 2 means here. We're talking about the means, the wait time, which is means. Once he give you guys X1 bar, X2 bar, you know it's about the means. So how do you state HO and H1? Well, HO is going to be easy, guys. It's always the equal sign. And what sign do you want me to put? I'm going to put 3 choices, guys. Don't give me 3 choices on the test. You just choose one. Which choice is the correct one? We're saying less than, exactly, Andrew, because it says the lowest in the area. Lowest means less than everything else. I agree. Get rid of those. That's the claim. All right. It's a 2 sample t-test, guys. Once you see S1 and S2 given, it's a t-test. And since I have 2 of them, we use 2 sample t-test. Let's run the test. Okay, stats, don't choose data. I don't have the actual data. I have summary. Okay, X1 bar, 4.5. S1 is 1.1. N1 is 45. X2 bar is 4.8. S2 is 1. N2 is 50. And we're testing less than. This is the alternative sign. Sorry. Right here. So let me just repeat. X1 bar, S1, N1, X2 bar, S2, N2. We're doing less than. Now for pooled, guys, let me explain something about pooled. If he doesn't say anything, you keep it at no by default. If he says, assume that the population variances are not equal, it's a no. But if he says, assume population variances are equal, is a yes. And if he says nothing, that means it's a no. On the test, guys, I'm gonna make a statement, tell you whether you should assume population variances are equal or not equal. If I say not equal, that means non-pooled. It's not pooled. And equal means pooled, yes. In our case, it's gonna be a no. Calculate. Okay, test the statistic, guys. Negative 1.385, and the p-value, look right here. I'm just gonna copy them. Eight, 4, 7. Okay, compare it with alpha, guys. Now it's gonna change. It's good now for HO. Do you guys agree with me that this p-value is bigger than what? Alpha. So what's the decision this time? It's not rejecting HO. It's gonna be what?
Fail to reject.
Thank you. Only you reject HO when p-value is less than alpha. If you fail to reject HO, guys, you don't say there is enough evidence. You start with there is not enough evidence at the 5% level of significance to support the claim. I'm not gonna write it down, but you write it down that, right? Just copy and paste, guys, that the waiting time for the restaurant patrons to be served is the lowest in the area. That's it. How do you use StatCrunch for this one? Watch, guys. You just go share screen with you first. Close this one. Go to stat. T-stat, to sample with summary, and just enter the values. So I got 4.5. Sample standard deviation 1.1. Sample size is 45. So you notice, guys, I'm trying to wear two hats tonight using StatCrunch and the calculator, which is not an easy task to keep doing this, but we'll try. Trying to sample standard deviation is 1, and sample size is 50. You see here for pooled, since we say it's off, we're select no, you don't touch this one, because once you select it, that means a yes. So don't select it. And we need to test that mu1 is less than mu2. Leave the 0 alone here. That's correct. You know, it's the same thing. And hit compute, guys. And let me show you. There you go. That's what I got. Next. A random sample of 8 apples of variety A and an independent random sample of 13 apples of variety B yielded the following weights. Do the data provide sufficient evidence to conclude that the mean weight of apples of variety A is different from the mean weight of apples of variety B? That should be easy, guys, to figure out how to state the null in the alternative. You know what? Instead of 1 and 2, I'm going to use A and B. Just so A and B here. Would you guys agree with me that different means this sign, that's the claim, and that will be the equal? And he wants a 2-sample t-test again. How are we going to run this test on the calculator, guys? You would have to put this data in L1, and you have to put this one in L2. If you're using StatCrunch, guys, you have to put this data in variable 1 and this data in variable 2. So let's do this. Okay. So L1, let me just type then. So bear with me, guys. 3.7, 3, 2.7, 2.8, 3.2, 2.5, 3.6, 3.4. Now let me delete the rest. Let's go to L2. I'm going to clear it. Okay, I have quite a bit in L2, but it takes me less than a minute to do it. 4, 3.9, 4, 3.9, 2.8, 3, 2.6, 2.5, 3.2, 3.6, 3.8, and 3.6. Ready, guys, for the test? It's to sample t-test. Now, this time, guys, we're going to choose data. L1, L2, don't touch the frequencies. We need to check that mu1 is not equal to mu2. You see now this is blinking. It's not selected, guys. Don't think that you selected the first one. You have to press enter, and now it's working. Pooled is no by default, and then hit calculate. So T is negative 1.506. P-value is, you must appreciate this p-value you've been hearing about throughout the semester, which is bigger than alpha. So what's the decision, guys? Fail to reject what? HO. And what's the conclusion? There is not enough evidence at the 10% level of significance to support the claim that mean weight of apples of variety A differs from the mean weight of apples of variety B. That's how you do it. And if you are to use static range, guys, I'm just going to tell you how to do it. Share a screen. Close this one. You have to put variety A right here. And you have to put variety B right there, put the data. For example, let's say I put some numbers here and we put some numbers there. Just anything, so you see how to do it. And then you go to stat, t-stat, to sample with data, not with summary, guys. You select variety A, then you select variety B. Don't touch optional here. Don't worry about it. You select the right sign, which is not equal, guys, and you just hit compute and you're going to get the same output, just like we did. Next. Couple more questions, then we will be done, guys. This is section 12.1. All right. A company wants to, so this is 12.1, guys. He will give you a certain distribution and he'll ask you, test the claim whether this distribution is still valid or the distribution has changed. For example, I want to share this example. I asked ChatGPT to create for me. Just a second. Let me share the screen with you. Okay. Look at this problem, guys. You are working as data analyst for a company that manufactures sports equipment. The company has recently conducted a survey to understand the distribution of consumer preferences for 5 different types of sport equipment: soccer balls, basketballs, baseball gloves, tennis rackets, and golf clubs. According to market research, the expected distribution of consumer preferences is the following. 20% prefer soccer balls, 25% prefer basketballs, 15% baseball gloves, 30% tennis rackets, 10% golf clubs. In a recent survey of 200 customers, the following preferences were recorded. So they surveyed 200 customers and they asked them, which one do you prefer out of those 5? And they have the results. Here's the question. Use a chi-square goodness of fit test to determine whether the observed distribution of consumer preferences is different from the market research distribution from this one. You know what, guys? I'm going to do this one before I do number 15, because this is more reflective of what you should know on the test. So you have a distribution of preferences, and the question is this distribution, use a chi test to determine whether the observed distribution of consumer preferences is significantly different from what we have. So we want to check if this distribution has changed or it remains the same. So I will show you how to perform, this test on the calculator and on StatCrunch as well. So let's do this one. Okay, so now let's do it on this side right here. So this is from the computer screen. So we have soccer balls, 20%. Let me just write them down first. And we have basketball, 25%. We have gloves, 15%. Then we have tennis rackets, 30%, and 10% golf clubs. Then when they surveyed 200 customers, they got the following. For soccer, 50 said, 40, 30, 60, 20. All right, guys, let me stop sharing and take you to what we're gonna do right here. Here's how you solve a goodness of fit test problem, guys. Just follow the steps and nothing would go wrong, just with any questions from section 12.1. The first thing, guys, is state HO and H1. HO will always be, guys, the distribution is as given to us. So distribution of preferences of sports equipment is as stated, or as given, or as claimed. You can put any word that would serve, this purpose. The H1 will be distribution of preferences of sports equipment has changed or is not as claimed. Now the question to you guys, you have to tell me where the claim is. It is an HO or H1. I'm gonna project the question one more time to tell me whether it is an HO or H1. It says, test the claim to determine whether the observed distribution of consumer preference is different from the market research expectation that we have here. What would you guys think now? Is it HO or H1?
H1.
H1, because he said it's different. If he wanted, the claim to be an HO, he would say, that's the claim that the preference did not change or remain the same. So it is an H1. All right, here is how you do it, guys. You need the observed values and you need expected values. So we need observed values and we need expected values. They will always give you the observed values, so they will be given to you. And the expected values will not be given directly to you, we'll give you percentages instead. And what you have to do, guys, is to take the percent of each category and multiply by the total in order to get the expected values. So the observed values, guys, are given right here. I have a 50, I have a 40, I have a 30, I have a 60, and I have a 20. For the expected value, guys, he gives me percentages, but these are not the expected value. The expected value will be a percent of the total. I have a total of 200 and he says 20%. So it should be 20% of 200. That would be a 40. For the second one is 25% of 200. That will be a 50. For the next one, 15% of 200 will be a 30. For the fourth one is 30% of 200 will be a 60. Oh, they're matching. And the last one is 10% of 200 will be a 20. You would go, guys, and put the observed values in L1, and you will put the expected values in L2. And let me show you how we do that. So go to Stat, Edit. I'm gonna clear the list. This is how you clear the list. Select L1, hit clear. I'm hitting clear right here. Clear, and then enter. And then look, do the same thing for L2, select L2, clear, and enter. Now I have them back. So let me put the values, 50, 40. Oops, sorry, it should be the other first one. 50, 40, 30, 60, 20. For L2, it'll be 40, 50, 30, 60, and 20. And now, guys, you go to this test, goodness of fit test, GOF test. Here it is, step tests. Scroll up, it's right there. So section 12.1, this is the only test that you need, guys, this one right here. Okay, are my observed values in L1? Yes. Are my expected values in L2? Yes. Now let me tell you what degrees of freedom is. Number of categories -1. How many categories do we have in this problem? 1, 2, 3, 4, 5. -1 will be a 4. And here's the tested statistic. It's a chi-square test. And look at the p-value, guys. 3.425. That's all I need. Okay, this is bigger than alpha, of course. What's the decision, guys? Fail to reject what? HO. And what's the conclusion? The conclusion will be there is not enough evidence at the 5% level of significance to support the claim that the distribution of preference is not as claimed. That means we're not supporting the claim. This is how you do that one. All right. Let me go back to my question, guys. So this one and another one, and we will be done. Let's do number 15. But before I do it, let me show students who are using StatCrunch how to use StatCrunch for this one. So share screen, StatCrunch. You go to stat. Okay, first of all, guys, you have to put the observed values in a variable, and you have to put the expected values in another one. Okay, observed. Let me copy them. So for observed, I have 50, I have 40, I have 30, 60, 20. And you need to delete the rest. If you don't delete it, you'll be in trouble because they're gonna count. Delete everything. And now for expected, guys. For expected, we just did them. 20% of 200 was 40. And then 25% of 200 was 50. Then 15% of 200 was 30. Then we had 60, and we had 20, I remember. Okay, run the test. Stat. Goodness of fit. Look, guys, it's obvious. Goodness of fit. Chi-square test. Observed is an observed. Expected is expected, and just hit compute. And look, guys. 4.5, is that what we got? Yeah, 4.5, and look, p-value 0.3425. Let's do the one that I have in your handout right here. A company wants to determine if its employees have any preference among 5 different health plans, which is offered to them. A sample of 200 employees provided the data below. Test the claim that the distribution of preference is uniform. Okay, HO. Distribution of preferences is as claimed. H1, guys, distribution of preferences is not for healthcare, is not as claimed. I want a student to tell me where the claim is. Test the claim that the distribution of preferences is uniform. Do you guys know what the word uniform means? If I guys, if I give people 5 choices, and I notice, just it doesn't matter, just people don't care, what choice, just to get either one would work for them. That means this distribution is uniform. For example, If I tell you the distribution of the grades in my class will be uniform, that means the same number of students will get A, B, C, D, and F. That's what uniform means. No difference. Everybody is the same. And here I'm asking you to test the claim that distribution is uniform, then the claim will be in HO here. These are the observed values. You already have them. So we have, we surveyed 200 employees, 32 chose plan 1, 18 chose plan 2, 30 chose plan 3, 55 plan 4, and 65 plan 5. But he didn't give me percentages, guys, to use it to find the expected numbers, but he's given me the key word. That's the claim that the distribution is uniform. So how am I gonna find the expected values and put them in L2? Does anyone have any ideas? I explained the word uniform to you, what that means. Uniform means everybody is the same. All plans are the same. All categories are the same. So how would you figure out the expected values? For each observed value, I should have an expected value. So I have 1, 2, 3, 4, 5. I should have 5 values right here. Okay, I'm gonna give myself the liberty and put in the answer, and I like it to figure out how I did it. You've been through 12.1, guys, you should know. How did I figure out that it's 40 each? Can someone tell me? The total in the sample, guys, is 200. And we have 5 categories. I just divide 200 by 5. Each one will get 40. Yeah, exactly. 200 divided by 5. These are in L2, expected values. Okay, let's run the test. So anytime, guys, he says uniform, test if the distribution is uniform or not. He's not going to give you percentages. He's going to assume this is what you're going to do. You're going to take the total and divide it by the number of categories, and then you will get all the expected values. They will be all the same. If you have 8 of those, you divide 200 by 8. If you have 10 of those, 1, 2, 3, 4, or 10, you just divide by 10. So that's how it works. So stat, edit. Okay, let's do 32, 18, 30, 55, 65. L2, guys. Let's do that. So 40, 40, 40, which is easy, actually. Just enter 40, 40, 40 each. Run the test. Goodness of fit test. L1, L2, number of categories. -1 is the degrees of freedom. Since I have 5, -1 is 4. We're good. And here's chi-square. The test statistic here is called chi-square 0. And you can put just chi-square without the 0, guys, if you like. Okay, look at the p-value, guys. I don't want you not just to be confused here. It's not 1.45. There is an E -7. E -7, guys, means you have to move the decimal 0.7 digits to the left. So it's going to be 0. Don't ignore the E, guys, which is less than alpha. We reject HO. And we reject HO, and the claim happened to be HO, so we reject the claim. So this is what you say here, guys. There is enough evidence at the 1% level of significance to reject the claim that the distribution of preference is as claimed or is uniform. It's not uniform. So we're rejecting the claim it is uniform. That means probably it's not uniform. All right. And the last question, which is from section 12.2. Please pay attention to this one, and we will be done once I finish this one. So I planned a 1.5-hour session, and I think we're going to meet the time. The contingency table below shows the results of a random sample of 200 registered voters that was conducted to see whether their opinion on a bill are related to their party affiliation. So we have the party, 3 different parties, and we have their opinion: approve, disapprove, no opinion. Test the claim, okay. Test the claim of independence, use alpha equal 0.05. Here's how you test it, HO, and H1. I'm going to show you how to state them, guys. And they are the same. No matter what the question is, the statement are the same. HO, guys, will be the variables are independent, and H1 will be the variables are dependent. So, but what are the variables, guys? There are two variables, the opinion and the party. So you would say opinion and party affiliation are independent. In the worst scenario, if you don't know what to say, just say variables are independent. And H1 will be variables are not independent. That means dependent or related. So opinion on a bill and party affiliation are dependent. And I think I want to just reword the question so it will be clear to you. So I'm just gonna put the question here. That's the claim that opinion on a bill and the party affiliation are independent. And use alpha equals 0.05. So where is the claim, guys? Is it in HO or H1? That's the claim that opinion on a bill and the party affiliation are independent. What do you guys think?
HO.
HO. And if I change this one?
H1.
Exactly. Okay, let's make it H1 for this. Good. Just be careful, guys, where the claim is, because your wording at the very end depends on where the claim is. So just be very careful. Read very carefully. For 12.2, if he says test the claim that they are independent, then it's in HO. If he says test the claim that they are related or dependent, that means it's in H1. And I'll make sure, guys, the word that I will be using if I give you a question like that, either ask you they are independent, dependent, or I might ask you related. Related, guys, means dependent on each other. That's what related means. Okay, how we're gonna run the test. I'm gonna show you how to do it on the calculator and in StatCrunch. To do it on the calculator, guys, you have to enter this data as a table. And this is a table that has 3 rows of data and 3 columns of data. So watch me doing this using the matrix option. Watch. You go to second, and then this guy right here, guys. X inverse. It shows matrix. You go to edit and press enter. And if your calculator doesn't show 3 by 3, you type in 3, and then you type in 3 by 3, and start entering the data. 42, 20. You're wondering why the data is there already, because I did this question with my student this morning. 14, 50, 24, 18, 10, 16, and 6. And you're done, almost done here. Quit. Now I'm gonna run the test. You go to stat, tests. It's a scroll up. Look, scroll up from here. And let me show you the test. It's this one for section 12.2, C. D is 12.1 and C is 12.2. Chi-square test, independence test. It's asking me, where are your observed value? I put it in matrix A. The expected value, guys, automatically are gonna come to matrix B. You don't need to do any work yourself, and just hit calculate. Here's the test statistic, and here's the p-value. Let's write them down. So I got 8.03, and p-value, it's big, 0.0905. What's alpha? 0.05. Do you guys agree with me that this is bigger than alpha? That means we're gonna what? Fail to reject HO. Conclusion, I'm gonna say that verbally. There is not enough evidence at the 5% level of significance to support the claim. Why do I use the word support? Because the claim is in H1. Or to conclude, you can use the word conclude. Look, why I'm saying the word conclude, because this is the word. The contingency table below show the results for that was concluded to see whether their opinion on a bill are related to their party affiliation. So we did dependent, which is actually speak, to the question. To be honest with you, I didn't read this carefully. I didn't see it until now. So, but we ended up testing exactly what they want us to test. So again, there is not enough evidence at the 5% level of significance to conclude or to support the claim that opinion on a bill and party affiliation are dependent, or you can use the word related. It doesn't matter, as I told you. Okay, how do you use StatCrunch? That's the last thing we do, and then we'll end this. StatCrunch is kind of tricky. You've done it, so this chapter, you know how we did that. So let me show you. Okay, for StatCrunch, guys, I need to mimic the table that you see in the question. So I'm just gonna copy it as is. And you have to start here with the headings right there. So I see party right here on the table. I'm gonna type it. And what's under party? I see Republican. I see Democrat. And I see Independent. Then here, what do I see next to party? Approve. Disapprove, and I see no opinion. And then you guys, you have to, let me get rid of this. And let's approve. Let's write what's under approve. I have 42, I have 50, I have 10. Disapprove, how many? We have 20, 24, 16. No opinion, I have 14, 18, and then what? 6. I'm ready to perform the test now. You go to stat. Please pay attention, guys, to this one. Tables, contingency table with summary. Now we need to select the columns. I have 3 columns: approve, disapprove, no opinion. This is how you select them, guys. I'm gonna press down and hold the control key. So I'm doing that right now in one finger, and you do this: approve, disapprove, no opinion. Row labels. You select the first one that you type right here in the corner, right here. Party. And you want the expected values, you can just select the expected, it will show you the expected values, and let me hit compute. And watch, guys. The test statistic is 8.0304. That's what we got. The p-value, guys, 0.905. That's what we got. And these are the expected numbers. We have 9 observed values and we have 9 expected values. 1, you see in parentheses, count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 expected values. And since the p-value is more than alpha, you fail to reject the null hypothesis, and you conclude that you don't have enough evidence to support the claim. That concludes the review, guys. I'm gonna stop the recording.